Okay, lesson 80, 18.2, 2D motion with variable acceleration. We did this with 1D motion in the AS recently. So what we had recently in vector form, velocity is the rate of change of displacement with time, and acceleration is the rate of change of velocity with time, which is the second derivative of displacement with time. Okay, and that's what we had before. Now when you do it in 2D, you just, like we did in the previous lesson, we deal with the i's and the j's separately. So key point, if s is x, which is a function of time, times I, plus y, which is another function of time, times j, then velocity is dx dt I plus dy dt j. And we can say v is x dot I plus y dot j. Or this acceleration, which is double dots. I don't use this notation very much, but you might see it somewhere. Okay, so 1 dot first derivative, 2 dots the second derivative. Right, example 1. The displacement of a particle at time t, s, is given by s is 4t squared I plus 3t minus 5t cubed j meters. Write an expression for its velocity at time t in seconds. Well, velocity is ds by dt. So we've got to differentiate the s here with respect to time. So what we've got, 4t squared differentiates to 8t, that's the I. And then 3t minus 5t cubed differentiates to 3 minus 15t squared in the j. Yeah, and that's meters per second. Example 2. The velocity of a particle at time t is given by v is sine 2 pi t in the I direction plus t squared j in the y direction. Work out its acceleration, velocity meters per second. Work out acceleration when t equals 1. So acceleration, which is dv by dt. Sine differentiates to cosine. And we've got that factor of 2 pi there. That's in the I. T squared differentiates to 2t. And it's in the j. Multiplied by the j. Acceleration when t equals 1. So we need our calculator in radians, unless you know it already. Calculator in radians mode. Acceleration 2 pi cos 2 pi, I don't need that bracket there, brackets overload, don't want that again. 2 pi times 1 I plus 2 times 1 j. Cos of 2 pi is 1, so this is 2 pi times 1, which is 2 pi times I plus 2 times j. Okay, so we did this before. The next part, if we differentiate s, we get velocity. If we differentiate velocity, we get acceleration. So we can go in reverse. If we integrate acceleration, we'll get v. Integral of a with respect to time is v. The integral of v with respect to time is s. And you've got to be aware of the constants of integration. Okay, so it says, as with differentiation, to integrate a vector, we need to integrate each of its components. So the acceleration of a particle is a is 6t squared I, 3t squared minus 8tj. Write an expression for its velocity at time t, given that v is 5i minus 6j when t is 0. Okay, so we want velocity, which is, now if you think, so s ds dt gives us v, dv dt gives us a. So if we've got a, the integral of a dt gives us v, the integral of v dt gives us s. And we need the constants of integration as well. So v is the integral of a dt. So it's the integral 6t squared I plus 3t squared minus 8t times j. So add 1 to the power, divide by the new power. So 6 divided by 3 makes 2. Next one, add 1 to the power, divide by the new power makes 1. And the next one, add 1 to the power, divide by the new power is j plus c. Now when t equals 0, v is 5i minus 6j. So therefore, c has to be 5i minus 6j, because all these t's are 0. So when t is 0, all that's 0, so that bit there has to make that initial velocity. Let's do some colouring in there, there. So it's that one there, and it's because of all these t's. All those yellows go together. T equals 0. So eventually we have, so what I'm going to do is I'm going to put this bit with the i's and that bit with the j's. So v is 2t cubed plus 5i plus t cubed minus 4t squared minus 6j. Okay, so a particle is initially at a point with position vector 2i plus j. So t equals 0, position vector 2i plus j, and velocity 4i plus 6tj meters per second. Work out its position vector 4 seconds later. Right, I'm going to call this v, I'm going to call this u for the Suva equations. So I've got t equals 4. We want to know its position vector, which we can think of as s. Well, s plus 2i plus the j is going to be the position vector. So we have to do s from using our Suvats, and then add on where it is at the start. And so we want s equals ut plus a half at squared. So we also need a. So we've got v is 4i plus 6tj. And v, and we need acceleration. Well, acceleration, do we need this one? Don't remember doing this before when I practiced it. I'm just going to stop. I might be going off track. T equals 0. R equals 2i plus j. Velocity 4i plus 6tj. T is 4. I might be doing it a different way. I think I'm doing it a different way from in the book, but never mind. So v, I'm just going to carry on. A, acceleration is dv by dt, which is going to be 6j. So s, which is ut plus a half at squared. So it's 4i plus 6tj, and that's times 4. Do you know what? I feel like I've gone off track here. I'm going to just start again with this example. Sorry about that. I just feel like it's going to... There's a quick way of doing this on saying in the book. So, start again. A particle is initially at the point with position vector 2i plus j meters, and as velocity v is 4i plus 6tj meters per second. Work out its position vector 4 seconds later. Okay, so they've said, so that R is the integral of V. Because I was doing differentiation, I felt like I was doing the ones from the previous page. So this is what I'm using here. dt. So it's the integral of 4I plus 6tj dt. So it's 4ti plus 3t squared j. So they add 1 to the power, divide by the new power for each one. So the 4, add 1 to the power, 4t to the 1, divide by the new power, stays as it is. And this one, add 1 to the power, becomes a 2, divide by the new power, becomes a 3. Okay, and then it's plus c as well. A particle is initially at the point with position vector 2i plus j. So t equals 0, r is 2i plus j. So therefore c is 2i plus j. And so r is 4t plus 2i plus 3t squared plus 1j. So what I've done there, that 2 is there, and this 1j is there. Okay. Yes, that's the same as what's in the book. So position vector 4 seconds later, so t equals 4, r is 4 times 4 plus 2i, 3 times 4 squared plus 1j. So I've put t is 4 in there, look, there and there. So r 18i plus 49j. And that's meters. That way definitely works. I'm not sure, I was going off track a little bit in the first one. That method definitely works. So I'm sorry about the hiccup there. Right, example 5. A particle of mass 4 is acted on by a force of 8i plus 12tj newtons. Initially, the particle has position vector 3i minus j meters and velocity 3i minus 5j meters per second. Work out its speed after 4 seconds, its position at that time. So we've got a mass and a force, so it's F equals ma. That means we're going to be able to work out the acceleration. So 8i plus 12tj is mass, which is 4 times acceleration. So therefore acceleration 2i plus 3tj. Okay, so initially it has position vector 3i minus j and velocity 3i minus 5j. Okay, so velocity is the integral of acceleration dt. So it's the integral of 2i plus 3tj dt. So it's 2ti plus 3t squared over 2j plus c. And then we've got when t equals 0, velocity 3i minus 5j. So therefore the c has got to be 3i minus 5j. And that's because there's a 0 there and a 0 in the j's. So we actually have velocity 2t plus 3 in the I plus 3t squared over 2 minus 5 in the j. So we want its speed after 4 seconds and its position at that time. I can do part A now. When t equals 4, b is 2 times 4 plus 3 in the I, 3 times 4 squared over 2 minus 5 in the j. So therefore V is 11I. 3 times 16 is 48, divided by 2 is 24, minus 5, 19J. So the speed is the square root of 11 squared plus 19 squared, which is 22.0 meters per second. Okay, and then we want his position at that time. So R is going to be the integral of V, which is this one here. So I've highlighted that to make sure I get the right one. It's the integral of 2t plus 3I plus 3t squared over 2 minus 5j dt. This is t squared plus 3t I. Add 1 to the power, divide by the new power, cancels out that 3. That's 5tj plus c. T equals 0, R is 3I minus j, so therefore C is 3I minus j, and R is t squared plus 3t plus 3 in the I, t cubed over 2 minus 5t minus 1 in the j. Just check that one's correct. Before I go any further, please. Good. And then it is t equals 4, R is 4 squared plus 3 times 4 plus 3 in the I plus 4 cubed over 2 minus 5 times 4 minus 1 in the j. 16 plus 12 plus 3, 31I. And then 4 cubed is 64, so it's 32, minus 20 is 12, minus another 1 is 11, plus 11 in the j. And there's another example. Example 6. The displacement of a particle at time t seconds is given by S is 6t squared I plus 3t squared minus 12tj. Work out the distance of the particle from its initial position at the instant it is travelling in the x direction. So when it's travelling in the x direction, what you've got is that velocity. So when it's travelling in the j component of velocity, the j component of velocity equals 0, okay, because in the x direction it's just got i's only, it hasn't got any j's, which is up here. Travelling is velocity. Right, so we need velocity, and velocity is ds by dt, so it's going to be 12ti plus 6t minus 12j meters. So I've differentiated this here, 12t, 3t squared is 6t minus 12j meters, and it's meters per second on its velocity. So the j component is 0, so 6t minus 12 is 0. So that happens when t equals 2 seconds. So we need to work out, so it's 2 seconds, it's travelling in the x direction. The displacement is s. So we need to work out s when t equals 2. S and t equals 2. T equals 2. S is equals to 6 times 2 squared I plus 3 times 2 squared minus 12 times 2 j. 6 fours, 24i. 12 minus 24 minus 12j. And then, so the displacement, the magnitude of the displacement is the distance from the starting point. It's going to be the square root 24 squared plus minus 12 squared And that's 26.8 metres from your calculator.